In this video, we will discuss about subset selection dimensionality reduction concepts, types of subset selection methods, advantages and disadvantages, and where this subset selection method can be applied. Bayesian selection is the process of selecting a subset of relevant features, variables, predictors, for use in model construction for several reasons such as simplification of models to make them easier to interpret, shorter training times, to avoid the curse of dimensionality, and enhance generalization by reducing overfitting. The smaller subsets of features are chosen from a set of many dimensional data to represent the model by filtering, wrapping, embedding. It is also known as variable selection, attribute selection, feature selection. The various subset selection methods are best subset selection, forward stepwise selection, and backward stepwise selection. Let's discuss one by one. As the name suggests, best subset selection finds the best model for each subset size. In other words, it produces the best models for one variable model, two variables model, and up to p variables model when there are p predictors. For example, when there are a, b, and c variables, best subset selection will evaluate a, b, c for a one-variable model, AC, BC for two variables model, and ABC for three variables model to identify the best model. Forward stepwise selection starts with a null model and adds a variable that improves the model the most. Or for a one-variable model, it tries adding A, B, or C to a null model and adds the one that gives the best result. For instance, let's say A is chosen. Then for a two variables model, it will try adding B or C and choose the one that improves the most. The forward selection algorithm is explained here by adding one by one variable with minimum error. Backward selection works in the same way as forward, but instead of starting with an empty set and adding features one by one, we start with a full set and remove features one by one. Thus we remove the features that cause the most error. The following are the advantages of subset selection. First, subset selection helps in simplifying complex models by focusing on the most relevant features, which can improve model interpretability. Second, selecting a subset of features can reduce the risk of overfitting, especially when dealing with a high-dimensional dataset. Third, smaller subsets lead to faster model training and prediction times, making the model more computationally efficient. Fourth, by selecting only the most informative features, subset selection can lead to models that generalize better to new, unseen data. The disadvantages are, first, information loss. Removing variables may result in loss of information, especially if the excluded variables have some predictive power. Second is search space complexity, that is the search space for selecting the best subset grows exponentially with the number of features, making exhaustive search impractical for large datasets. Third is sensitivity to noise. Subset selection methods can be sensitive to noise in the data, leading to suboptimal feature sets. Fourth is collinearity issues. Subset selection may struggle with highly correlated features, as including or excluding one may affect the perceived importance of the others. Subset selection can be applied in predictive modeling, feature engineering, biological and medical research, signal processing, text mining, natural language processing. Thank you for watching this video. If you like this video, subscribe this channel and press the bell button.